So today we're going to be talking about this reaction and limiting reactants with this reaction. So starting off, we see we have the Cu2O plus carbon reaction, and this is how much of each we are given. So now we have to find out which one's the limiting reactant and which one's going to determine how much of the product is formed. So we can start off by using 4 moles of Cu2O, what we were given, and we can convert that to how many moles of carbon are going to need to react with that completely. So we use the molar ratio we have. You see between the reactants, it's a 1-to-1 molar ratio since the ones aren't written in, they're just assumed. So that means 1 mole of Cu2O is going to react with 1 mole of carbon. We can cross out these, and we are left with 4 moles of carbon needed. We, when looking at the moles we were given, see that we have more moles than we need to react, which means that we have plenty to react with. This means that this is the limiting reactant because this has excess. Now we can do this the other way to prove that it's the limiting reactant. We can use the 6 moles of carbon, same molar ratio, just flipped, carbon to 1 mole of Cu2O. Cross these out, and that gives us 6 moles of Cu2O needed. Now, when we look at how many moles we were given of it, we only have 4 moles. That means we don't have enough moles to react with carbon, meaning that this is the limiting reactant. This determines, the Cu2O determines how much product is going to be formed, because only 4 moles of Cu2O are available. Okay. Now we can get into a little bit of a harder problem. As you see, we were given grams this time, not moles. That means we have to convert each one into moles. So let's start with this first one. 2.6 grams of Cu2O. So to convert it into moles, we're going to use the molar math, and I gave it to you here, but otherwise you'd have to calculate it on the periodic table. So that's 143.1 grams per 1 mole of Cu2O. These two cross out the grams, and that's going to give us a certain mole. We don't have to calculate and then continue because this is going to be calculated as we go. And then we use the same principle as used before. 1 mole of Cu2O can react with 1 mole of just carbon. And now we can get our answer. So we plug that into the equation. We do 2.6 divided by 143.1. Multiply that by 1, which is going to give us the same answer, and we get 0.018 moles of moles of carbon needed. Now, to make the next problem easier, we can also calculate how many moles of this we are given to compare if we have enough. Because it's a 1-to-1 molar ratio, that also means that we had 0.018 moles of Cu2O. That's how much we were given. This is how much carbon is needed. So now we have to figure out how much of carbon we were given. That's 8.3 grams. Again, we use the molar mass, which is 12 grams of carbon per 1 mole of carbon. And that is going to give us, divided by 12, it's going to give us 0.69 moles of carbon given. Now, just by looking at these two numbers, we are going to need 0.018 moles of carbon to react. But we have a very large excess of it. That means that this is the limiting reactant. We can only react 0.018 moles, which means that there's also going to be an excess of 0.69 moles minus the 0.018 moles, which is that minus the 0.018. That's going to give us 0.67 moles of excess carbon floating around that's unreacted because it has nothing to react with. Only 0.018 moles of carbon were able to react with Cu2O. Now, moving on to the next part, how much how much copper was formed? Well, we know that 0.018 carbon was used, or 0.018 moles of Cu2O. Either works because it's a 1-to-1 molar ratio. We can do 0.018 moles of, let's just do carbon, was used. And now we have to find how much of copper was formed. Well, again, we have to look at the molar ratios, but they're not 1-to-1 this time. 1 mole of carbon reacts to form 2 moles of Cu. So our molar ratio is 1 mole of carbon and then 2 moles of Cu. Now we multiply that. 0.018 that we probably have on a previous calculator, and then we multiply it by 2, get 0.036 moles of Cu that was able to be formed. Now we can move on to you guys doing a problem. Here is the reaction that you guys have already spelled out for you. On some AP test, you're going to have to form this reaction by what they give you and what forms. And you're going to have to balance it yourself. But for now, I'm giving you the reaction, and this is how much we have. We have 0.46 grams of hydrogen gas and 1.56 grams of nitrogen gas. And here are the molar masses of both that you guys can use. So start off with finding the limiting reactant, and then find how much changing this NH3 forms. Can make it more complicated. So now you have a second to pause the video, and when your turn, I'll explain everything to you. So after you've had a time to do it by yourself, this is the answer to it. So first, what I did was I took 0.46 grams of H2, and I found how many moles there was by dividing it by the molar mass, and then I used the molar ratio of 3-to-1 to figure out how many moles of N2 are needed. So I got how much moles of N2 are needed for 0.46 grams of H2, and now I'm figuring out how many moles of N2 did I have. So I used the molar mass to find out the moles, and I got 0.111 moles of N2 available. Now that means that there was an excess amount of N2, which means that H2 is the limiting reactant, because only 0.077 moles are needed. So I was able to use 0.077 moles because I knew that that is how much N2 is going to react. Because I know that that's how much reacting, that's not the excess number. You never use the excess number. You use the amount that you know is reacting. Then I can plug it into the equation to find how much NH3 is formed. So use the molar ratio again, 1-to-2, and that is how many moles of NH3 is formed. So now that you've had a chance to do a few problems, try to do some harder problems and see how far you can take this information.